Hi, I'm Dr. S. V. Prakash, who will be presenting you a presentation on engineering branches and its importance. It's more useful for most of the 12th standard and the PUC pass-out students, wherein the students want a brief idea like which field of engineering should they select after the 12th or the entrance exams. So I hope it helps you a lot, and if you like it, please do subscribe for the channel. So we'll see different branches of engineering. The different branches of engineering are aeronautical, automobile, artificial, architecture, biomedical, computer science, chemical, civil, electronics, electrical, information science, instrumentation, IEM, also called as industrial engineering management, mechanical, mechatronics, marine engineering, mining, machine learning, petroleum, robotics, and finally the textile engineering. So we'll come to aeronautical engineering. The student can opt for any of these 21 branches of engineering with respect to their field of interest and pursue in their field of engineering, which gets them a degree and help finally at the end of finishing the engineering what exactly they will be doing. I'll be going to present for you in this presentation. So aeronautical engineer, all of you know it is morely related to aeroplanes as basically what you think. Little in advance, it goes in depth. Along with aeronautical, it goes to astronautical and avionics. What is aeronautical? It's the primary field of engineering concerned with the development of aircraft and spacecraft. Along with that, aeronautical engineering and astronautical engineering and avionics, which is a combination of electronics part of the aerospace engineering. That's what they're going to study. So starting from the scratch, like design, development, manufacturing, controlling, servicing, everything they will be going to studying in the basic 4 years degree of aeronautical engineering. And you will be placed in most of this aeronautical engineering, and in our country a lot of aerospace related industries are coming up for manufacturing, design, R&D, and lot of companies R&D sectors have been set up like Boeing and Airbus. They own R&D centers in Bangalore and surrounding and in different parts of the country. So that's what an aeronautical engineer will be studying in this branch of engineering. Next, automobile. So an automobile engineer will also be as related to automobile sector. He will be studying more on bikes, cars, trucks, buses from the scratch, like designing of different components for an automobile like mechanical, electrical, electronic, software, safety engineering as applied to design, manufacture and operations of different automobiles. So automobile engineering field is research intensive and involves different application of mathematical models and formula. The study of automobile engineering is to design, develop, fabricate and test vehicles. That is, finally it has to meet lot of standards set up by the automobile standards, ISO or the ISC, it is called as Indian Automobile Standard Designated Company. Like finally the emissions has to meet the BS6 standards, the crash tests and different performance tests, reliability tests. All this automobile has to satisfy and meet the standards, then only it can be implemented on the road. So production, development and manufacturing are the three major functions in this field. And finally, artificial intelligence. Artificial intelligence is a part and parcel of little computer science engineering. And I'll just brief you what is artificial intelligence. It is people thinking of replacement for a human being in performance of an operation process or in so many other places where these machines can perform and replace human beings. So artificial intelligence is a simulation of human intelligence processed by machines, especially computer systems. Specific application of AI include expert systems, natural language processing, speech recognition, mission vision. So basically what exactly this is, expert system, a proper software, natural language to understand like Java, C, Java plus, C plus, or it can be Raspberry Pi, and so many languages or machine learning softwares available you should know to use. Speech recognition. So all of you might have heard of Alexa. Today, what is the TV remotes we take, whatever the speech we give, it understands and gives the output in form of the requirement. So mission vision. Finally, the sensors, the different sensors which will go into sense and give the output as per the requirement. So AI engineering is an emerging discipline focused on developing tools, systems, processes to enable the application of AI in real-world context. In contrast to prevalent rush to develop capabilities and process individuals, tools, and other things. So AI engineering asks a different set of questions. How can AI help human achieve mission outcomes? What are the limitations of AI systems in practice today? So it's a very challenging and upcoming branch of engineering which can be used for different applications, and there is no limit for this. It is just penetrating through each and every field of engineering and helping human beings to perform much better, efficiently, and more reliably. So AI and ML, what is the difference? Artificial intelligence versus machine learning requires skills. AI is more stuff like a software, whereas ML is more of like a hardware in simple words. Because AI is a catch-all term for smart technologies, necessary skill set is more theoretical than technique. So ML is more about technical. Machine learning professionals on the other hand must have a high level of technical expertise. They should have multiple field of engineering knowledge to make a machine learning understand and implement and make a machine out of it. So AI skills are algorithms, techniques for analyzing them, machine learning, and how to apply techniques to draw inference from data. The ethical concerns in developing responsible AI technologies like data science, robotics, Java programming, program designing, data mining, problem solving. So all this, it comes under AI technologies. So in AI, people should understand and know how to extract the data and make use of the end application. So this is all about AI, and in machine learning, implementation of this AI into a particular application is known as ML, machine learning. Where artificial intelligence is the overall appearance of being smart, machine learning is where machines are taking in data and learning things or performing things about the world that would be difficult for humans to do. So wherever it can be in mining industry, in the border security force, you might have seen different robotics working as security guards or the Air Force defense mission. So all these things, what we see in movies and all, will be the future in machine learning. So in the security, in the defense, lot of this army, navy people can be replaced by these machines. In simple words, robotics. So ML can go finally beyond human intelligence. So when there is a guess that it is going to take over the human beings. So architecture engineering. As all of you know, architecture is the most oldest field of engineering. Architecture is nothing but the design or the aesthetic look of a house, shopping mall, temple, castle, mosque, you name it. Anything, the outer and the interior design of a building is known as architecture design. And it is 5 years of engineering compared to other fields of engineering. This is the only field of engineering where a student has to study for 5 years. And in the entrance also, along with whatever the entrance exam, they do have to take this NATA exam and clear the NATA exam, and they will be eligible to go for architecture. Very interesting field of engineering, and nice. Without architecture, no building can be executed, bridge can be executed, dam can be executed. So with respect to different constraints, the architecture design is going to design a building and give it to you. Then biomedical and biomedical electronics. So anything, any machine that is used in the field of medical today, it can be a CT scanner, MRI scan, ECG machine, or it can be anything. All this, the picture, a dialysis machine is shown. All these machines are designed and developed by this biomedical or the medical electronics. They are the engineers who bridge a gap between the medical and the engineering field, and they are going to design a machine, a control system, testing system, and give out the results in a highly efficient, without error, 0% error. That is the level to which a machine should work, and that is the level equipment or a machine will be designed, manufactured, and given for the usage. So most of the companies like Siemens, GE, and all, they are into this company, and a lot of scope is there for this equipments and implementation and usage of this equipment. This is what we will be doing as a medical engineer, medical electronics engineering. So computer science engineering, all of you know, the most demand subject in the present world. It is computer science engineering. It is not only computer science, it is in specific divided into another 5 or 6 streams known as big data analyst, cloud computing, data analyst as the data science, IoT, Internet of Things, cyber security, AI and ML and blockchain and so on. Lot of fields it has been gone into. So basically a computer science, what is computer science? It is the study of algorithmic process. See, whatever the mathematical process or the mathematics what we used to solve till today using pen and paper, today computers can solve the same problem, wherein if you take 5 to 15 minutes for a particular problem based on its size and iterations involved, the same problem a computer can perform in nanoseconds and give out the end results. So this is what is the algorithmic process it is known as. So computational machines, we need machines for this, so different hardware and software are used to process this algorithmic process and computation itself. So based on the software we develop, the computation process it is going to happen and give the end results. So basically this is the function or what exactly a computer science engineer will be doing. Again, based on the applications and for different applications, the computer science engineering is being diverted into different fields like big data, cloud computing and so on. I'll just brief you what is big data. Now all of you are using a lot of social media softwares like Facebook, Insta, Snapchat, so many Twitter and all. Now in Facebook, for example, one customer who is logged in and uses this Facebook, he will store some 500 pictures, 400, 500 pictures. There is no limitation for that. Just imagine 1 million people using Facebook and 100 pictures if each one stores, what will be the size of the data? You must be knowing the practical problem in your mobile phone. As the data increases, your machine slows down and it is going to show that there is no space for data storage. So where does this Facebook guy gets the server to store so many millions of pictures, videos? So that is the most challenging thing known as the big data analysis or the big data storage. So here big data includes capturing data, data storage, data analysis, sharing, transfer, visualization, querying, updating, information privacy and data source. So if one user logs into Facebook and he wants to extract some data of 3 years, 4 years, just at the click of the mouse he gets the data. Sort of this big storage of TB of data, how exactly within that fraction of data that data is recognized, retrieved and displayed on the screen is a very challenging thing. For a common user he won't understand the problem, but the background people who are working on that and analyzing this kind of data, it's known as big data. It is not only there, banking sector or it can be in medical field, wherever a individual data is stored, extracting that data, processing that data is known as big data analysis. What is cloud computing? So a cloud computing is nothing but just replacing the high-end servers or the big servers that we use in computer laboratories or in offices. All these servers, the hardware part can be replaced by something known as cloud computing. All the data can be stored in cloud computing, that is in the clouds, without a hardware. We can go for hiring the storage system through Amazon or Google or different people who give this service. By monthly prescription or annual prescription, we get the storage space which is stored in satellite or in the clouds as it is simply called, and we can analyze our data and use this data. But only thing, if servers are there, it will be safe in our place. If cloud computing is there, it will be in some other side. So this kind of replacement for servers is known as cloud computing. Data analysis and science, as I told you about the Facebook and the Instagram example, just like that in banking sectors or in so many media, the data has to be stored and analyzed and properly bifurcated for proper usage, and we can extract retrieval of the data within fraction of minutes or nanoseconds is known as data science or data analytics. It's the process of inspecting, cleansing, transforming, modeling data with the goal of discovering useful data and supporting the decision making. This all is known as about data science and analytics. So we'll be studying more about that in computer science. Next is IoT. IoT is nothing but Internet on Things. Today every product is on Internet on Things. Our mobile phone is connected to internet, our computers, laptops, it can be your printer, it can be your geyser, smart houses, locking systems of the houses, you name it, everything is connected to Wi-Fi. Our cars are connected to Wi-Fi, our bikes are connected to Wi-Fi, everything is connected to internet. So making each and every product accessible to internet, taking data, sending data is known as IoT. Industry 4 in industries, it is known as every missionary in industry with respect to IoT. A few years back, they plan to go for Internet on Things, because a machine can be serviced, it can be maintained, it can be programmed, people sitting in different parts of the globe, and they can control the machinery. So that is known as Internet on Things. So it is easy, because if a machine breakdowns, a German machine breakdowns in Bangalore, a person did not come from all of us way from Germany to repair, wherein few years back how people used to service. Sitting in Germany, he can repair, service, program, or he can make the machine work by sitting in any part of the globe, and that is the advantage of Internet on Things. So there was something known as Industry 4 where all the machineries went on Internet on Things. Now the things have changed, it is Industry 5. Using IoT, people are going for more automation, controlling the machinery through Internet and making it more automated. That is Industry 5. So people are going in depth, beyond limitations, beyond expectation, happening through Industry 4 and Industry 5. Revolutionary things are happening in the industry. So finally, cyber security. Doing all the above things is very easy, but securing the data, maintaining the data is most challenging. So that is what you'll be doing in cyber security. In your WhatsApp and all, you might have seen previous, like anybody can access your data, your messages or anything. So there was something called as end-to-end encryption. That is what is known as cyber security, as security for data transfer. So everything that we do today should be secured, and for that what we do is what we'll be studying, cyber security. So AI and ML we already studied, we just went through, and next it is blockchain. A blockchain is a growing list of records called blocks that are linked together using cryptography. It is also known as trustless and fully decentralized peer-to-peer immutable data storage that is spread over a network parchment, often referred to as nodes. So using different types of nodes or security codes or different things, every program from the start to end, it can be encrypted by data. So all of you must be knowing, for each and everything you use data. Banking system use data. For your WhatsApp you use a code, a security code to open and close. Your mobile opening and closing, everything is coming with this blockchain programming and encryption. So it is more secure. Chemical engineering. So all of you know, all the petroleum industry, gasoline industries, where petrol and gas are extracted from the earth surface or the water surface, processing it until the end usage. That is the field of engineering, chemical engineering, what we'll be studying. In chemical engineering, in many aspects of plant design, operation, including safety and hazard assessment, process design and analysis, modeling, and all this, controlling the plant, everything is the work of a chemical engineer. So basically, you will be using different principles like physics, chemistry, mathematics, biology, and economics of efficiently use, produce, design, transport, and transfer energy and materials. So petrol, diesel, gas, everything what we are using today is processed and sent by a chemical engineer in the plant. So this is a field of engineering what usually the chemical engineers is going to study. Civil engineering, all of you know, it is the oldest form of chemical engineering that is available on the earth. Anything that you make, construction of houses, roads, bridges, canals, dams, airports, sewage system, pipelines, structural components of buildings, railways, everything is done by a civil engineer. He is the one who designs, plans, executes, implements from the scratch to the end finishing. He will stand and get the work done. So today, everything that is happening, the infrastructure what we are using is done by civil engineers. Very interesting field of engineering. A civil engineer can work on his own, work in companies, work in multinationals. They can do miracles out of this field of engineering. So electronics and communication engineering, all of you know, it is a part and parcel of every other branch of engineering. Today it can be mechanical, civil, electrical, chemical, everything is followed by electronics engineer. Because electronics plays a very important role today. The hardware, what we call, is any software is easy to work, but to make it work, hardware is required. That's what an electronics and communication engineering does. So basically, electronic engineering is an electrical engineering discipline which utilizes nonlinear and active electrical components such as semiconductors, diodes, triodes to design electronic circuits, devices, integrated circuits, their systems, printed circuit boards, and so on. Today, every component is becoming in small and small in sizes. iPods you might have seen, where a big tape recorder before of 1 feet by 1 feet has been made into 1 inch by 1 inch iPod, a music system where radios especially work, the music system works, the storage system works, everything. So that is the level to which a EC engineer is working. In the picture, an Arduino is shown. An Arduino is one which has gyroscope, a GPS system, everything that is available in the mobile, which shows your GPS system, gyro, just tilt it, your screen on, off, touch screen, everything it works because of this Arduino. So it is a very interesting and challenging field wherein everyday new technology, new components are researched and innovated and are put in place to work. So it's a very interesting field of engineering, and most of the software engineers are followed by the electronics and communication engineering. Electrical engineering. It is a field of engineering, all of you know, again, a oldest where power supply is involved. It can be AC or DC, and electricity, where the components work making use of electricity, and electrical engineer is involved. So it is an integration of electricity, electronics, and electromagnetism. And it emerges identifiable occupation in the late half of the 19th century after commercialization of the telephone, telegraph, electrical power generation, distribution, and usage. So very old and most useful form of electrical engineering, and power electronics, electromagnetic waves, microwave engineering, nanotechnology, electrochemistry, renewable energies, mechatronics, controls, and electrical material science. Everything is a part of electrical engineering. And the latest trend is the EVs, electric vehicles, electric scooters, electric cars, auto rickshaws, trains, aeroplanes. All this is electric thing where a fossil fuel machine is replaced by electric machine. This is what will be the next future within a year or two. And by 2025, all the petroleum vehicles will be stopped and electrical vehicles will be used. That is that, and government throughout the globe is following. So this is the future of electrical engineering. And information science, and it is again morely related to communication. It is an academic field which is primarily concerned with analysis, collection, classification, manipulation, storage, retrieval, movement, dissemination, and production of information. So in the information technology, giving the data, procuring the data, analysis of the data, and using the data is what exactly is done in this system, in this field of engineering, making use of electronic data and information. So IT is typically used within the context of business operation as opposed to personal or entertainment technologies. Next, instrumentation. So instrumentation is morely related to measuring equipment. All of us, we know that we use different measuring equipments like pressure, temperature, pH value, force, and speed. For all this, we do use different measuring equipments. Pressure gauge is used, thermometer is used, pH level, humidity level is used. To measure force, the speed recognizer is used, a speedometer or the tachometer. All these measuring equipments that are designed and used are used in instrumentation. So in instrumentation, it is more of measuring systems, control systems, what an instrumentation engineer does and use it. So that's what you will be studying in instrumentation and technology. Industrial engineering and management. All the above industries, what we discussed till now, are easy to implement, design and implement and make it work. But controlling is very important, because without controlling, no system will going to work efficiently. So an industrial engineer or a manager will going to implement the process, control the process, and check for the efficiency and reliability of the system. So it's more concerned with optimization of complex processes, systems, or organizations by developing, improving, and implementing integrated system of people, money, knowledge, information, and equipment. So you're going to implement and integrate all this together and you're going to finally check whether a system is performing or not by using advanced management techniques like lean manufacturing, agile manufacturing, Six Sigma standards, information system, process capability, and DMAIC. What is DMAIC is, which is used in Six Sigma standards, like define, everything should be defined neatly, like what to do, how to do, when to do, everything. Then measure whether everything is performing according to the definition. Then analyze that is compare with the standards and what actual the reality results is, and if there is deviation, improve the process, then control the system. So we have to do this to see that each and every machine will going to work highly efficiently and performs highly according to the standards, because according to Industry 5, it is more of automation, robotics, IoT and things, which is a very expensive process, and initial cost or investment is very high. After investing so much, we have to see whether the system is going to perform to highly efficiently and highly reliably so that losses are minimum. So mechanical engineering. Now we spoke all these different fields of engineering. It can be an Arduino, a rig in the petroleum engineering, or a computer with hardware. It can be anything. Today, what we wear, the clothes, the shoes, the watches, the specs, the mobile phones, laptop, mobile, everything is manufactured by a mechanical engineer. So without him, nothing, no component can exist in the world. Everything, it can be a fan, tube-light, bulb, anything, everything is manufactured and used by making use of this mechanical engineer. So it is a field where people are doing each and every product according to the design, according to the requirement by a mechanical engineer. He is the one who designs and performs each and everything. And there are different subfields in mechanical engineering like design, mechanics, dynamics, thermodynamics, materials and structural analysis, electrical integration of computers. Everything is done by a mechanical engineer to make a machine work, along with the different computer assisted programming like CAD, CAM, product lifecycle management, design analysis, manufacturing plants, industrial equipment, machinery, heating and cooling system, transport system, aircraft, watercraft, robotics, medical devices, weapons and others. So all this is the job of mechanical engineer, who does everything for a simple human being person to work. It can be a cap, it can be a shirt, pant, everything is done by a machine, wherein the machine is designed and manufactured by a mechanical engineer. And it's also known as the evergreen branch of engineering, because without this, nothing can exist in the world. It can be car, bike, tire, it can be anything you name it is done by a mechanical engineer. So mechatronics. Mechatronics is another subfield of mechanical, wherein it is more of integration of mechanical, electronic and electrical engineering system, and it includes a combination of robotics, electronics, computer science, telecommunication, system control and product engineering. So originally the field of mechatronics will intend to be nothing more than a combination of mechanical and electronics. That is what is mechatronics engineering is. So marine engineering is morely related to things that float on water or inside water and moves. So ships, boats, submarines, pipeline, everything that comes under marine engineering, and it includes the engineering of boat, ships, oil rigs and other marine vessels of structures, as well as oceanographic engineering, oceanic engineering or nautical engineering. So everything that is related to water, that floats on water, under the water, comes under marine engineering. Mining engineering. A mining engineer may manage any phase of mining operations from exploration, discovery of the mineral resources through feasibility study, mine design, development of plants, production, operation to mine closure, taking into consideration all the other factors like environmental conditions, everything. So a mining engineer must therefore be concerned not only with the production and processing of mineral commodities, but also with the mitigation to the damage of environment both during and after mining as a result of the change in the mining area. So all of you know mining means blast all of you might have heard of in reality. Lot of dynamites, RDX is blasted in the mining industries. So when this blast happens, the surrounding area gets affected. So in order to protect that, a mining engineer should take proper care of the environment, and he should work on that. So machine learning, already we discussed what is machine learning. In general, I'll just explain you how this machine learning works. Data mining, algorithm, classification, learning, networks, deep learning, AI, and automation, or the autonomous. So these are the 6 or 7 steps that is a machine learning engineer should work. So making use of artificial intelligence, finally analyzing in AI, and making a machine work is what exactly is machine learning, which we discussed already, and that's what we're going to be studying. So petroleum engineering, as I told you, petroleum engineering, extracting of crude oil or natural gas from the surface or the water surface, is the work of petroleum engineering. Is a field of engineering concerned with activities related to the production of hydrocarbons, which can be either crude or natural gas, and making use it to the end user in the form of in the automobiles or in the gas cylinders, or it can be anywhere, making the product usable according to the requirement of the human being is known as the work of the petroleum engineering. So it's quite challenging, and mostly people planning to go abroad and work in rigs in Saudi, Australia, USA, or in any of the other part of the rigs, people can think of a petroleum engineering. So robotics and automation, any mechanical engineering, integration of things and making the robot applicable for end use is about robotics and automation. Robotics is an interdisciplinary field that integrates computer science and engineering. Robotics involves design, construction, operation, and use of robotics in different fields. Today, especially, you can see on the Mars rover is roving and doing research. In the medical field, in the absence of a physical doctor, robots are performing operations, doing scanning, taking certain decisions, making use of artificial intelligence, and doing certain operations. In each and every field, robotics has entered. Nuclear plants, it can be in mining, or it can be in security, or in borders, it can be anywhere. Making use of artificial intelligence, robotics are performing certain operations based on its own decisions and securing the thing or making a very high reliable work out of this. So robotics integrates the field of mechanical engineering, electrical engineering, information engineering, mechatronics, bioengineering, computer engineering, control engineering, software, mathematics, and among all this. So making use of all this, automation engineers are the experts who have the knowledge and ability to design, create, develop, and manage machines and systems. For example, factory automation, process automation, and warehouse automation. So these are all the works of robotics and automation. So future is more of robotics and automating everything that an ordinary equipment that used to work, making use of human beings by the switch of a button in a mobile phone or in a report. So that is known as automation. Finally, the last branch of engineering is the textile engineering. It is a major engineering which is based on the conversion of fiber into yarn and yarn into fabric. And for that, lot of very high-fi machineries are available today. These machines will go on to see that highly and efficiently this yarn is converted into fabric, and fabric is designed into different textures, colors, and everything, and it is used for different applications. And these are then dyed or printed, fabricated into cloth, which is then converted into useful goods such as clothing, household items, upholstery, leather, or artificial leather. It can be anything. That is what a textile engineering does, and in various industrial products. So lot of things this textile engineering is used for, and different types of fibers are used to produce yarn. Cotton remains the most important natural fiber, so it's treated in depth, and there are many variable processes available at the spinning and the fabric forming stages, coupled with the complexities of the finishing and collaboration process in the production of a wide range of products. So along with textile engineering, silk technology, and so many other different types of engineering is available. And based on all these different fields of engineering, a student can select according to his own interest what he has to become. And in his own field of interest, he can become expert, innovative, and pursue his career in that field of engineering. So every branch of engineering is important. It depends upon the individual how to select and go with respect to his own interest. And to get this data, a lot of research has been done into engineering journals, Wikipedias, Google search engines, and the data has been procured. And a lot of things, I think it should be useful, and it is made to understand, make an 12th standard boy or 18-year boy to understand these things. Hope he gets a clarity in this, and if you like this presentation, kindly subscribe for this channel, and thank you very much for following this. Thank you.